All right, we're still in 4.4 and we're starting task 5, factor by grouping. The steps and their justifications for factoring a polynomial by grouping are within the following task. Place the factoring steps in the correct order. All right, so when I do this, I like to kind of work it out on my own first. So we're going to say 4x cubed plus 8x minus 9x minus 18. All right, so if I want to do this by grouping, I'm going to group with parentheses. And remember, this is 8x minus 9x, so we have subtraction here, so we can do plus and minus. Like, you don't want to have parentheses without knowing that you're still adding those together. Like, we're not changing it to multiplication. All right, so on this first part where you've got a 4x we can pull out. And then we're left with x squared plus 2. All right, so this binomial has a negative 9 we can pull out. And we are left with x plus 2. Because negative 9 times 2 is negative 18. All right, now these should match. So let's look. Something is not right. Okay, so it looks like the original problem was supposed to be an x squared. So there's just a typo here, which the textbook is also made by a human, so we know that there are mistakes. Okay, let's see if we can correct this. All right, so if this is an x squared, let me put a 2 here, which means we can pull out an x squared instead of an x, which means we're just going to get rid of the squared term. All right, that should fix it now. So 4x squared times x is x cubed. 4x squared times 2 is 8x squared. All right, so just make sure you know that that is a squared term there. All right, so the first step is not really a step. It's just having the polynomial. And then the next step is going to be to group these in binomials. So we're going to have this step here. And then the next step would be to factor out the greatest common factor. So that's going to be this step here. And then from here, like I said, we wanted these to match. So we can use distributive property to say that x plus 2 is one factor, and 4x squared minus 9 is your other factor. All right, now we're not finished because those are both perfect squares, and hopefully that you recognize those right away, that 4x squared and 9 are both perfect squares. So we're going to bring down x plus 2. That's as low as it can go. It can't be factored anymore. But 4x squared minus 9 is a difference of squares. So I know that's going to be 2x plus 3 and 2x minus 3. And again, that's one of those rules that's very important to remember. Difference of squares is something you're going to see in this class a lot and on the ACT. All right, so we've got the x plus 2 and the 4x squared minus 9. Okay, so that was the next step. That's right here. And then the difference of squares. Factoring the difference of squares is your last step. All right. This one says match each factoring step with its justification. All right, so it looks like this is the original problem. So let's go with given polynomial. All right, and then we need to say the next step would be to group them using parentheses. So that would be this. So I guess that is the group terms with a common factor. And then beyond that, we are going to factor out the greatest common factor of each binomial. So that would be factor out group's common factor. Okay, really would have liked that to say binomial instead, but I think that's the right one. And then after that, we've got factor out the common binomial. So that would be here at the bottom, would be that next step. And then last is factor the difference of squares. All right, so that's just matching the steps with the description. So if you have to explain what these are, this is a good way to explain it. All right, it says, can you factor the polynomial in task 5 by grouping terms as this instead of the other way? So as you can see, like they've got the x term and the x squared term reversed. So let's look at that real quick. So 4x cubed minus 9x plus 8x squared minus 18. So what they did was use commutative property basically to switch the order of these two and see if it still works the same way. So now we can't factor out a 4, but we can still factor out an x. So we're left with 4x squared minus 9 in the parentheses. Over here, we can factor out a 2, and we're left with 4x squared minus 9. So you can see now our common factor is 4x squared minus 9 is one factor, and then x and a positive 2 is our other factor. And then again, this is a difference of squares. So 2x plus 3 and 2x minus 3 is this in factored form, and then x plus 2. So what we did was grouped different terms together, but if you look up here above, you're still going to get the same thing. So 2x plus 3, 2x minus 3, x plus 2. So even though they grouped the x cubed and the x squared together, which is usually what you're going to do if it's in standard form, but this just shows you if you group it differently, you still can get the correct answer if you do all the steps correctly. All right, that is factor by grouping. We are going to move on to task 6. All right, 4.4, task 6. Factor a polynomial to solve a real-world problem. Previously, you have used the zero product property to solve factorable quadratic equations. Okay, again, we did this in Math 2, so hopefully you remember that. You can also use this property to solve equations involving higher degree polynomials that can be factored. All right, a landscape architect is designing a marble flower planter for an outdoor mall. The planter should hold 4 cubic feet of soil. The architect wants the length of the planter to be 6 times the height and the width of the planter to be 3 times the height. The sides of the planter should be 1 foot thick. Because the planter will be on a sidewalk, it does not need a bottom. What should the outer dimensions of the planter be? All right, so it's always nice when they give you a picture, a visual image of what they're talking about. So you can see this is 6x, the height is x, the width is 3x, and then you've got this 1 foot here. We also know that the planter should hold 4 cubic feet of soil. All right, now it says use a verbal model. So the length, 6x minus 2, the width is 3x minus 2, the height is x, and the volume is 4. All right, to write an equation with that, we do length times width times height, because this is a rectangular shaped flower box, and we know that the planter is supposed to have 4 cubic feet. All right, so the first thing you're going to do is multiply these together and get your your cubic equation in standard form. So the first thing you do is multiply each of these together. That puts the equation almost in standard form right away, and then you just have to subtract the 4 to the other side. So this is a cubic polynomial in standard form, and we know that because it goes from highest exponent to lowest. All right, now as mentioned above, it says they're going to use the zero product property to factor this out. So the reason they couldn't go straight from here, factored form, to the answer is because this 4 was not included. So they had to solve it or multiply it out, then put it in standard form, and now they're going to refactor it. Okay, so 18x squared, if you factor by grouping, 18x squared is the greatest common factor of those first two terms. 4 is the greatest common factor of this. Once you finish factoring, okay, 18x squared plus 4 will not factor any further. This is set equal to 0, so now we can use the zero product property, which says we set each factor equal to 0 and solve to get the x's, or the solutions. Okay, these are sometimes called zeros as well. All right, so if you solve this using a quadratic equation, subtract 4, divide by 18, and then take the square root of both sides, you can see that you get the square root of a negative number. Remember, we did imaginary numbers, so square root of negative is imaginary. We can't have an imaginary distance for a flower box, so that doesn't make sense. So if you set x minus 1 equals 0, add 1 to the other side, x equals 1. So that's the only solution that makes sense in this case. So it says which factoring technique is used first to solve the equation. All right, so they use parentheses to group it. So that was factor by grouping. Which property justifies the step that reads this equals 0 and this equals 0? So that's the zero product property that we used for quadratics, and now we're going to use it for polynomials. Why do the solutions x equals plus or minus the square root of negative 2 over 9 not make sense in this situation? Again, this would be an imaginary solution. So because we're talking about a real world situation like the flower box on the sidewalk, we need length, width, and height to be all real numbers. So an imaginary solution would not make sense. All right, if you have any questions, please let me know.